Hello students, good evening everyone. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. And I hope I am perfectly audible and visible to each and everyone present over here. Those who are watching the particular session, just mark your attendance. So here we have successfully completed our 4 chapters. Now we are moving to another chapter, that is the classification of elements and the periodicity in properties. As you can see over here, this is a 2-part, right? The name itself is a 2-part. The first part we are going to discuss about the classification of elements. Some of the scientists are there, they are coming to classify the elements according to some particular properties, right? So first part is the classification of elements, and the next one periodicity in properties. We are going to discuss about some of the properties, how they are affecting the periodic table, right? Ready? Hi Arush, good evening. Durgeshwar, good evening. So today in this particular session we are going to mainly focusing on these 3 topics. That is about the genesis of periodic classification, how we can classify the elements in a periodic table. Then we are discussing about the Mendeleev's periodic table, which is our old one, right? Then the last one we are going to discuss about the modern periodic table or the modern periodic law, which we are used now. Ready? So let's start with the periodic classification here. So what are observing here? Some images are given here, right? Here it is starting from one of the scientists, Dobereiner, then Newlands, Mendeleev, and modern periodic table. So this is the classification of elements when we are started. So the first scientist who is started classify the element is the Dobereiner, and his classification is known as the Dobereiner's Triads. I hope you can see the picture clearly, right? So after Dobereiner, another scientist came, that is Newlands, and he again classified the elements, that is known as the Newlands law of octaves. Then the father of periodic table, Demerits of Mendeleev, right? So Demerits of Mendeleev is the father of periodic table. He introduced the periodic table first. Then after that, Moseley, he is a scientist Moseley. He classified the elements according to some other criteria. So he introduced a modern periodic table or the long form of periodic table which we are using now. Fine. Now let us discuss one by one. What do we mean by the Dobereiner's triads? Hi Akshat, good evening. Arush, we are going to discuss one by one here. We will be starting from the Dobereiner, then we will move to the Newlands law of octaves. Fine. So what do you mean by the Dobereiner's triads? Do you have any idea about the name triads? Is there any idea? So as we already know, tri means there will be something related to 3, number 3, right? A group of 3, yes, correct. So here Dobereiner, a scientist, he classified the elements in a set of 3 elements. Those 3 elements are having the same chemical properties or the similar chemical properties, right? So here according to his law, he says that if you are taking 3 elements, right? For example, I am taking A, B, just for a representation, A, B and C are the elements, right? For example, if I am taking the atomic weight of A and C, right? If I am taking the atomic weight of A plus atomic weight of C divided by 2, which means I am taking the average, right? I will be getting the atomic weight of B. So what you are observing here? What you are observing here? We can say that the atomic weight of middle element, that is our B, is having the weight or approximately the average atomic weights of the other 2 members. Did you got the point? Did you got the point? What is the main basics of the Dobereiner triads? If you are taking any set of 3 elements, those 3 elements are having the similar properties, right? Then if you find the atomic weight, we can say that if you are taking the average atomic weight of first and third element, it will be approximately equal to the atomic weight of second element. Clear? Akshay, these are clear now. I have already repeated. If not clear, we will be explaining with the example given here. See? So for example, I am taking the lithium element, right? Lithium, sodium and potassium is a set of triads. And the individual atomic weight of lithium, sodium and potassium is also given here, right? For example, so the atomic weight of lithium is 7, right? Which is given here. And the atomic weight of sodium is 23. And the atomic weight of potassium is 39, right? According to law of triads, the average weight of lithium and potassium, that is if I am taking 7 plus 39 divided by 2, that should be equal to the value of atomic weight of sodium, right? 39 plus 7, 46 by 2, that is equal to 23, right? Which means Dobereiner's law is applicable here. Is that clear now? Akshar, is that clear now? Arush, which point want to repeat? Okay, I hope it is clear now. This is the first set of triads, it is lithium, sodium and potassium. So these elements are belong to the same set, right? So they are having the similar chemical properties and it is again according to the law of triads, right? Then here in the case of calcium, strontium and barium, they are having similar properties. If you are taking the average of these two elements, you will get the answer is approximately equal to 88.5. Clear? Triad means a group or set of 3 elements. That is known as the triads. So in the case of calcium, strontium and barium, they will be getting the average atomic weight of these two elements, approximately 88.5 here. And here also it will be 35.5 plus 127. If you are taking the average weight of chlorine and iodine, you will get the approximately the weight of bromine, that is around 81.25. Clear? So these are the 3 set of Dobereiner triads we have to keep in mind. Is that clear? Akshat, this is not a new board syllabus, I think. This is a chapter we are going to discuss in the grade 11 class. Okay, fine. So, then what will be the demerit of these? These are the merit, right? So, he is the first scientist. Dobereiner is the first scientist who grouped the elements according to the atomic weight. So, this is the merit of this Dobereiner law of triads. Then, in the case of this particular law, it has some demerits, right? All the known elements could not be fixed in this triads. That is one of the demerit of this law, right? So, we can say only the 3 set of triads which is applicable for the other elements, right? For example, if you are taking fluorine, chlorine and bromine, right? Fluorine, chlorine and bromine. If you are taking the average atomic weights of fluorine and bromine, it will not be equal to the atomic weight of chlorine, which means that all the given elements are not applicable according to the Dobereiner's triads. That is the most important demerit of the Dobereiner triads. Clear? Okay, fine. Now, after Dobereiner's classification, the another scientist came, that is known as the Newlands, John Newlands, right? He's a scientist as well as a musician. So, what he did like that, he will be arranging the elements in the increasing order of their atomic weights. So, what he observed that, he will be observing that all the first element, right? All the first element is having the properties of the every 8th element. Let us see by example. So here, right, for example, if I am taking lithium here, if I am comparing the lithium with the sodium, because from lithium to sodium it is the 8th element, right? It is the 8th element. So every 8th element is having the similar properties to that of the first element. That is why the name of this classification is given as octaves. Oct stands for 8. Clear? Is there any doubt how the classification is happening? He is arranging the elements in the increasing order of atomic weight. Then he just classified the first element. For example, if you are taking the lithium, after lithium, the 8th element will be sodium. 8th element will be sodium, right? So, what you are observing here, the sodium is having the similar properties to that of the lithium, which means that every 8th element is having the same properties to that of the first element. Octave means oct stands for 8. So, here 8th element is having the similar property. That is why they are giving the name of octaves. Clear? Then he is already a musician, right? That's why he compared this classification in the musical notes. In the musical notes, there will be sa, re, ga, ma, pa, da, ni, sa, right? Which means that the first sa and 8th sa is again repeating with different notes, right? So that is why he classified or comparing this classification with the musical notes. Okay, I hope you understand. So if you are asking about the octave of beryllium, it will be magnesium. Then boron, it is aluminium. For carbon, it will be silicon. Yes, as you can observe here, right? Lithium is having the similar properties to that of sodium. Then sodium is having the similar properties to that of potassium, right? Then for beryllium, it is magnesium and calcium. For boron, it will be aluminium. For carbon, it will be silicon. If you are counting the numbers, you can say that if we are taking the first element as carbon, the 8th element will be silicon. That's why they are having the similar properties. Then for nitrogen, it is phosphorus. Oxygen, it is sulfur. And for fluorine, it is chlorine. Clear? Then what you are observing here, after calcium, this law is not applicable, right? Their properties are like that only when you are comparing the chemical properties. So if you are taking any reaction with water, acid or base, anything, so they will be having the similar properties. That is why he found that it will be every 8th element is having the similar properties. It is the nature of those elements. Clear? So what will be the demerit of this law of octaves? Anyone? See, he has already classified the elements in the increasing order of atomic weight, right? So he has just classified the elements in the every 8th element is having the similar properties to that of the first element. But what will be the demerit or the drawback of this law? From the table you can see. So this law is applicable only up to calcium, right? After that, this law is not applicable, right? So this is a drawback of this law of octaves. The system worked well only for lighter elements up to calcium and failed to for the heavier elements, right? Failed for the heavier elements. Then as you are observing here it is fluorine chlorine, right? There is no name for the helium neon argon krypton, which means that he failed to explain the existence of noble gases. Okay, when we are discussing about the periodic table, you will get an idea about what you mean by the noble gases, right? So group 18 elements like helium, neon, argon, krypton, xenon, these elements are known as the group 18 elements or the noble gases. So he failed to explain the existence of noble gases. That is one of the drawback of the Newland law of octaves. Clear? Is there any doubt? Now, after Newland's law of octaves, who will be the new scientist? Now, first image. Yes, Mendeleev, right? Before that, we need to get focused on the, according to our competitive exam, we need to focus on the Lothar Meyer curves also before that. So here Lothar Meyer is another scientist. He has classified the elements in the increasing order of atomic weight, but he plot a graph, right? He plot a graph between the physical properties like atomic volume or atomic weight, right? So he is a scientist who classified the elements in the ratio of the atomic weight. Now let us see what is he doing. What is his observation? So this is the Lothar Meyer's plot. So what you are observing here, in the y-axis it is atomic volume, right? Y-axis it is atomic volume, and in the x-axis it is atomic weight. So what you are observing here, is there any particular properties here? Durgeshwar, you are almost right, but if you are asking about the drawbacks or demerits, you need to give like this point, right? It is failed to for the heavier elements, not for the lighter elements. Clear? Okay, here. So these are the atomic volume versus atomic weight graph, right? So if you are comparing the elements in the topmost of the curve, that is lithium, sodium, potassium, rubidium and calcium. Whenever you are discussing about the periodic table, you will get the idea that this lithium, sodium, potassium, rubidium and calcium are belongs to the same group, first group element, right? Same group, which means they are having the same chemical properties. So we can predict that from the Lothar Meyer's curve, all the elements which is present on the topmost or top of the curve will be having the similar properties. Is that clear? So the elements at the similar position of the curve have similar properties. For example, these topmost, right, lithium, sodium, potassium, rubidium and calcium is having the similar properties because they are occupying at the same position, right, similar position. Then for example, if you are taking beryllium, right, beryllium is the middle here, then magnesium, then calcium, strontium, barium, right. So these are also having the same chemical properties. Then last one, here, right, fluorine, chlorine, bromine and iodine. Again, these are also same group elements having the same chemical properties. Clear? So, just read the first sentence. Elements at the similar position of the curve have similar properties. Just leave about these elements. Right, elements at the similar position. So for example, if I am taking the same position, means topmost of the curve. First element is lithium, right? Durgeshwar. Hi Sonu Khan. So lithium, sodium, potassium, rubidium and calcium, right? Because they are belong to the same position. I mean topmost of the curve, right? Topmost of the curve. So they are having the same chemical properties. So whenever you are taking about the talking about the periodic table, we can say that the lithium, sodium, potassium and rubidium, they are belong to the same group, which means they are having the same chemical properties. Is that clear? The first. Video stop. I mean, Ashibhai came here. Okay, I hope I am audible now, right? Okay, fine. So here what do you mean by the second point? The curve's peak indicate the elements with largest volume, right? So here y-axis it is atomic volume, right? So topmost of the curve means it will be having the largest atomic volume, right? Largest atomic volume. So these elements are having the largest atomic volume. Okay, I hope you understand about the second point, right? Is there any doubt? Now they are giving some names here. When you are discussing about the complete periodic table, you will get the idea about alkali metals, alkaline earth metals. So you can say that at highest peak, like lithium, sodium, potassium, rubidium and calcium, these elements are known as alkali metals, right? These elements are known as the alkali metals. Okay, are you still confused with the second point? Durgeshwar and Arush. Okay, just focus about the calcium here, right? Calcium, if I am finding the atomic volume here. Right, if I am finding the atomic volume here, which means that atomic volume is high, right? Are you getting my point or not? So if you are having a curve like this topmost point is known as the peak of the curve, right? Peak of the curve. So here in the y-axis it is given in the atomic volume. That is why they are having like that. For the peak of the curve, they will be having the maximum volume or the largest atomic volume. Is that clear now? Okay, I hope you understand. Now here the ascending portion of the curve, right? Ascending portion means just increase and then this portion, right? Ascending portion of the curve is known as the halogens. That is fluorine, chlorine, bromine and iodine are known as the halogens here. Then this beryllium, magnesium, descending portion means here, descending, decreasing, right? Descending portion means beryllium, magnesium, then calcium, strontium and barium. They are the alkaline earth metals, right? Alkaline earth metals. So once we are completing about the complete periodic table, then we can go back to the Lothar Meyer's concept. Then you will get the correct idea about the elements in the Lothar Meyer's curve. Did you get the basic idea about the curve? I mean Lothar Meyer's classification. Now Durgeshwar, calcium is having the highest atomic volume here. Because in the y-axis it is given atomic volume, right? These are the atomic number, atomic weight, right? These are the atomic weight versus atomic volume. So we can say that calcium is having the highest atomic volume, not atomic number, right? Okay, fine. So here, this is one of the important work which was done by the Lothar Meyer. He has just classified. Instead of giving some random idea, he will be just plotted versus atomic volume versus atomic weight. So it was good, right? But again, there has some limitations for this also. That's why we are not considering Lothar Meyer's work as a proper classification. Clear? Just for a reference, we are giving the Lothar Meyer's classification here. Now, who is the next one? I mean, who is the next scientist? Henry Moseley's work when we are using the longest form of periodic table or the modern periodic table. The last scientist, right? Henry Moseley. His work is accepted now. So who is the next scientist? It is Mendeleev, right? Yes, Dmitri Mendeleev. He is known as the father of periodic table. So again, Mendeleev is also arranged. At the time, there is only 63 elements are present. So he arranged the 63 known elements in the increasing order of atomic weight, right? Increasing order of atomic weight. So he arranged in a chart of or a table, right? That table is known as the periodic table, in which the elements are arranged into 7 horizontal rows, right? 7 horizontal rows and 8 vertical columns, right? 8 vertical columns. These columns are known as the groups and rows are known as the periods, right? Periods. So according to Mendeleev, he said like that all the elements in the same group, right? The properties of the elements are the periodic function of their atomic weights, which means that at a certain interval they are repeating their chemical properties. That is known as the periodicity. So this law is known as the Mendeleev's periodic law. Okay, who is our first scientist? It is Dobereiner, right? He failed to explain all the elements with the classification, how we can classify it according to atomic weight. But here, according to Mendeleev's periodic table, we have given more idea about the periodic table, right? We can see what are the important features of the modern Mendeleev's periodic table. Then you will get an idea why he is considered as the father of periodic table, right, Arush? So here he classified the elements on the valency property, we will be discussing later. Then he made oxides of some elements, that's also we are going to discuss in the next class. Then they predicted the properties of undiscovered elements, even though he is not having the idea about the new elements, but he predicted their properties also. Clear? Now let us see what is the periodic table given here. So are you able to see? So this is the Mendeleev's first periodic table, which is the first used periodic table which is introduced by the Mendeleevs. So here it will be having 7 rows, right? 7 rows are present here and total 8 columns are present. These rows are known as the periods and 8 columns are known as the groups, right? So don't get confused with here. This is like the representation of these elements. So as you can see over here, there will be some gap, right? Are you able to see? There is some gap, which means that these are the undiscovered elements. Then also he has given some space for the undiscovered elements, which means that they are having, he predicted that these element is having the property similar to that of the aluminium and boron. Clear? Is that clear? Don't get confused with the periodic table given here. Our new periodic table is very interesting. Okay, I don't know whether it is possible or not. Okay, here, right? So here in the case of some of the elements is having the atomic weight of 44 and 68. So we don't know which element it is, but Mendeleev predicted that these elements will be having the same properties that of the boron and aluminium. So he left a space in between, in the below place of the boron and aluminium, right? Arush, is that clear now? So after getting the modern periodic table, we can say that which are the elements given here. So that are the main importance of the Mendeleev's periodic table. Now let us see what are the important features of the periodic table, right? The elements are arranged into 7 horizontal rows known as the periods and 8 vertical columns known as the groups. We have already discussed, right? Then when you are focusing on the periodic table, you can say that these 8 groups are given number as 1, 2, 3 in Roman numbers, right? They are given in the Roman numbers, and they will be subdivided into A, B categories, right? A, B categories, that is given in the second point. These 8 groups were labeled by Roman numbers and subdivided to group A and B based on their similarities, right? Clear? Because of their similar properties, he kept in the same box. He had done some experiments based on that, then he understood that they will be having the similar properties. Clear? Then, the group 8 consists of 9 elements arranged in triads. So, this is our group 8, right? This is the group 8. So, what are you observing here? This iron, cobalt, nickel, this is a set of 3 elements, right? Set of 3 elements. So, this is known as the triads. Again here rubidium, rhodium and palladium, right? This is also triads. So, in the case of group 8, it will be considered as triads, a set of 3 elements, right? Clear? Now, the last point, there are many gaps left blank of the periodic table for the new elements who is going to be discovered, right? We have already seen in the case of this space, right? These 3 elements having the space in between here, which means they are going to discovered, having the similar properties that of the boron and aluminium. Then, in the case of noble gases, right? In the case of noble gases, they are placed in a separate group called zero group. According to Mendeleev periodic table, the group 18 elements are known as a zeroth group element or group 0 elements. Clear? Yes, Dobereiner also gave the concept of triads, but according to him, it is according to the atomic weight, right? Average atomic weight will be equal to the weight of these second element, right? Second element is having the average atomic weight of the other 2 elements. Basically, triads means a group or set of 3 elements. Is the points are clear about the Mendeleev's periodic table? So, this is the better image of the Mendeleev's periodic table. So, as you can see over here, these are the periods, 7 periods and 8 columns. 8 columns means 8 groups. They will be subdivided into A and B category because of their properties. So, here the first group, it is hydrogen, lithium, sodium, potassium, copper. Here they are having the same, almost similar chemical properties, right? So, they are considered the same box. Then rubidium and silver, cesium and gold. Again, subdivision is happening here. In the group 8, it is triads, a set of 3 elements. In the case of noble gases, they will be separately given in the group 0. Clear? Now, what will be the merit of Mendeleev's periodic table? After getting idea about the merits, you will be get an idea about the why he is considered as the father of periodic table, right? So, this is a systematic classification of elements based on their properties. It categorizes the elements in their systematic manner, symmetrical manner, right? So, this is the first systematic arrangement of the elements in the increasing order of atomic weight. He will be dividing all the elements, all the non-elements, non-63 elements in the different groups as well as periods having the similar chemical properties, right? Then, he has left some space for the new elements which is going to be discovered later, right? He predicted that that element will be having the same properties that of the existed elements. Clear? Now, in the case of some of the elements, Mendeleev already corrected the atomic masses of some of the elements by studying their positions in the periodic table. Clear? For example, this is beryllium. This symmetrical manner, not sympathetical manner. It is a systematic arrangement. Those who are having the same properties belong to the same group. symmetrical. So even though he has given some merits for the periodic table, but they have some drawbacks, right? They have done some drawbacks. So what is the drawback of the periodic table? The first point is about the position of hydrogen, right? In some cases, hydrogen is having the properties to that of the group 1 elements, and sometimes it is having the properties of the group 18 elements also, right? Group 18 elements also. So he failed to explain the position of hydrogen, where hydrogen has to be placed, right? So it is unable to locate the position for hydrogen. This is one of the drawback or the demerit of Mendeleev's periodic table. Clear? So now if you are focusing about the modern periodic table, you can say that hydrogen is having a separate position in the middle, right? They will not be considered in the first group as well as the 18th group. Is that clear? Now the position of isotopes was not enlisted or determined yet. So what do you mean by isotopes? Do you have any idea about the isotopes? So what do you mean by the isotopes? Okay, same atomic number, then it will be having the different mass number, right? So we have already know what do you mean by mass number as well as atomic number. Atomic number means total number of protons or electrons present in the nuclei. Then mass number means total number of protons and neutrons, right? So the isotopes are the compounds which is having the same atomic number but different mass number. So according to us, we are saying like that all the elements which is having the same atomic number, they will be having the similar chemical properties, right? But here Mendeleev failed to explain the position of isotopes according to their chemical properties. Is that clear? Then lanthanides and actinides, when we are discussing about the complete periodic table, we will be discussing about the F block elements, right? So these lanthanides and actinides are the F block elements. So these elements do not follow the Mendeleev's periodic table because their position was anomalous. They are not known, right? Then according to Mendeleev, the elements should have similar properties in their groups. Clear? In the groups, they will be having the similar properties, but there will be some restriction, right? There will be some restriction. For example, here some of the cases copper and potassium is having the same group, right? But if you are asking about the chemical properties, some of the cases it will be having some different chemical properties. So he again failed to explain the position of these potassium and copper like elements in the same group. Clear? These are the main drawbacks or demerits of the Mendeleev's periodic table. Is there any doubt? Then if you are focusing about the particular element platinum and gold, right, aurum or gold. So platinum and gold is having the similar properties, but they are comparing or they are giving the position into different groups, right, different groups or different positions. So that is again one of the drawback or the demerit of the Mendeleev's periodic table. Arish, we have already studied the metals and non-metals part, right? So what do you think, hydrogen is a metal or non-metal? So again we are repeating the Mendeleev periodic table here. Then after that, okay, fine. So here after Mendeleev, another scientist came, that is Henry Moseley. He is the father of modern periodic table, right? Modern periodic table which we are using now. It is introduced by the Henry Moseley. Here the main difference is that he arranged the elements in the increasing order of atomic number, right? Not about the atomic weight. So in all other classifications like Dobereiner Triads, Newlands law of octaves or Mendeleev's periodic table, even though in the case of Lothar Meyer's concept also, they are classifying the elements in the increasing order of atomic weight, right? not about the atomic number. Here the new scientist came, he said like that we can arrange the elements in the increasing order of atomic number, not about the atomic weight. Clear? Then he predicted the law like that the physical and chemical properties of elements are the periodic functions of their atomic number. As the atomic number of the elements increases, the properties also changes. Clear? That is the exact definition of the physical and chemical properties of the elements are the periodic function of their atomic number, not about the atomic weight. So you may get question like this, what is the difference between modern periodic law as well as the Mendeleev's periodic law? So what is the difference between modern periodic law and the Mendeleev's periodic law? What will be the difference between Mendeleev's periodic law and the modern periodic law? Okay, in the modern periodic law, it is asking about the atomic number, but in the case of Mendeleev's, it is atomic weight, right? So same point is repeated here, and again in the case of modern periodic table also, it is arranging into 7 horizontal rows, right? 7 horizontal rows known as the periods, and 18 columns. 18 columns are present there. These 18 columns are known as groups. So as according to the modern periodic table, in the case of Mendeleev's periodic table, there is no any transition elements, right? But in the case of modern periodic table, which is seen here, which we are using now, okay, which we are using now, you can say that here there will be D block elements, I mean transition elements are also present, right? So what you are observing here, 7 horizontal rows, these are the periods. Then 18, total 18 columns are present in the modern periodic table. They are known as the groups. Clear? Durgesher, I am not sure about that. So this is a classification of elements, right, according to the long form of periodic table. So as you can see over here, hydrogen is having the separate position here, right, separate position, and these elements are having the same, those elements which is present in the same group is having the same chemical properties. So these elements are known as the first group element, second, third to 12 group element, then 13 to 18 group element. This 18 group element is also known as the 0th group in the case of Mendeleev's periodic table. Now what are the features of these modern periodic table or the long form of the periodic table? Again, they are arranged into 7 periods and 18 columns, right? 7 periods and 18 columns. Then in each group, the elements with similar valence shell configuration. I hope you must have idea about the electronic configuration, right? Electronic configuration. So if you are saying here, I hope you can see the screen, right? So in the case of hydrogen, the electronic configuration is 1s1, right? And in the case of lithium, it is 2s1. This is the valence electronic configuration. Sodium, it is 3s1. So if you are taking this element, it will be ns1, right? This will be ns1. As the number of periods increases, the n value also changes for the first group elements, right? Which means that the same electronic configuration elements that belong to the same group, right? The elements with a similar valence configuration are arranged in the same group. Clear? Okay, in the new form of periodic table, it will be group 1, 2, 3 and 12, 13 and 18, right? Not about 1A, 2A, 3A present. Okay, the first group element is known as the 1A according to the Mendeleev's periodic table. So this is the term which we are going to discuss in the next class about the block elements, right? In the case of periodic table, we will be classifying the elements in the different blocks. So if the last electron of the element is entering into the s orbital, they will be called as s block elements. If it is entering into the p orbital, it will be p block element. If it is d, it will be d block element and so on, right? So s, p, d and f block elements are present in the complete periodic table. That is the third point given here, and the case of these elements, right? So what you're observing here, some of the elements are arranged in the bottom portion of the periodic table, right? These elements are the part of the 6th period and 7th period respectively, right? Sixth and 7th period respectively. So these elements are known as the F block elements. So when you are discussing about the F block elements, you will get an idea about that. In these elements, the last electron is entering into the F orbital of the valence shell. So they are known as the F block elements. Clear? So this is a clear image of the periodic table of the elements. 1, 2, 3 groups are also present. These 1A, 2A, these elements are known as the 1, 2 elements, and 3B, 4B, 5B, these are known as the 3 to 12 group elements, and 3A, 4A, 5A, 6A, these are known as the 13, 14, 15, 16 and 17, 18 respectively. Clear? Is that clear? No, orbits and orbitals are different. So orbits mean whenever the electrons are revolving in a circular path, that is known as the orbit. I hope you must have idea about that, right? Orbitals means here in the case of subshell, we will be dividing this into S, P, D and F orbitals. Okay, just go through the new form of the periodic table. There will not be any existence of these elements, right? These names. It will be 13, 14, 15 and 16 represented. Now let us practice 1 or 2 questions based on the topic we have covered in this class. So here is our first question. Which of the following is a Dobereiner's triads? So what will be the answer? Which of the following is an example of Dobereiner's triads? Yes, option A, right? Lithium, sodium and potassium. So if you are taking the average atomic weight of lithium and potassium, it will be equal to the atomic weight of sodium, that is 23. So option 1 is the correct answer here. Here is the next question. I think it will be little bit difficult for you. When you are memorizing completely about the periodic table, then you will get the idea about this question. So the element that does not belong to the same period of the remaining elements in the modern periodic table. So option D is the correct answer, which means palladium, right? So if you are moving to the periodic table given here, right? So what are the given options here? Platinum, palladium. So these are the four elements in the given option, right? So osmium, iridium, platinum and palladium. So these osmium, iridium and platinum belong to the 6th period, right? This is the 6th period. Then palladium is belong to the 5th period. Clear? Is that clear? So once you are getting idea about the complete periodic table, you will able to answer this type of question. Is that clear? Okay, that's all about from my side for today. So we have discussed about the classification of elements, right? That is the first part of our chapter, classification of elements. So what we have seen? We have seen the different type of classification, right? Starting from the Dobereiner triads, which means that they are arranged in a set of 3 elements having the similar properties in the increasing order of atomic weight, right? But it failed, right, that it is applicable only for few elements. Then the next scientist came, Newland's law of octaves, right? He arranged the elements in the increasing order of atomic weight, and he found that all the 8th element is having the similar properties to that of the first element. That is why it is known as the Newland law of octaves. Again, he failed to Again, he failed to explain the properties of all the elements above calcium, right? So this is one of the demerit. Then Mendeleev scheme, he has already given the Durkheischer. Is it possible? I mean, if it is possible, it is necessary to remember the elements. Otherwise, it will be difficult. So you can use any mnemonic or trick for the memorizing the complete periodic table, which will be available in the YouTube. So you can use your own method. So we cannot predict the JE paper, right? Question will be asked from any of those, especially for the inorganic chemistry chapters. Question will come from any part of the chapter. So we can't predict the questions. So it is necessary. If possible, it is mandatory to remember all the elements. Arush, as your choice. If you are able to memorize those elements in the period wise, it is fine. If it is group wise, it is also fine. You should be aware about all the elements in the group 80. All the elements in the periodic table. So Mendeleev's periodic table also we have seen. Then after that, last periodic table, that is the Moseley's periodic table. The only difference is that Moseley has arranged the elements in the case of increasing order of atomic number. Clear? Okay, I hope you understand about the concept. In the next class, we will be discussing about the introduction to modern periodic table. We will be discussing the complete periodic table, how they are classifying the elements in the different blocks, and how to predict the position of an element also. So thank you so much all of you. See you in the next class. If you really like the session, hit the like button, share this session to your friends also, and subscribe our channel. And if you want to get the session PDF, you need to join our Telegram channel also. So thank you so much all of you. See you in the next class. Bye bye.